Um, I think another question I have to do with that is, can you kind of explain why Newtonian mechanics doesn't observe, we don't observe it like quantum mechanics, like, or because this is another thing. Is it possible that it does happen the same? It's just um we only see, say, one of multiple probabilities happening at once. So do you kind of get what I mean? Like, if you scaled it up,
Yeah.
is there something that could explain why things don't behave like that at our scale? Is it
Well,
like,
I mean, Newtonian mechanics. If you look into what replaced it with special relativity, um, you realize that Newtonian mechanics was an approximation
yeah,
at the scales that we and speeds that we were talking about on Earth.
yeah,
You know, it only breaks down when you talk about things traveling close to the speed of light, really. Like, because the relativistic correction factors are tiny, they're negligible unless you're traveling close to the speed of light. So that's why Newtonian mechanics seemed to explain everything, because on Earth, things we were dealing with, that's all we were testing it with. It only breaks down if you test it, in situations where you're not dealing with like throwing a ball, but you're looking at a spaceship traveling 9 tenths the speed of light.
yeah.
Then
So
the theory breaks down.
so does that mean, but does that mean that there's like, basically, does quantum mechanics explain everything, like small and big, then?
The well, I mean, yeah, basically, I think, yeah. I mean, it explains it in a microscopic, in a quantum form, but then it therefore also explains the macroscopic as well. And it's the same with special relativity. It explains both throwing a ball and a spaceship. It's just that Newtonian mechanics only looked at it from the ball, small, the low speed type. It didn't look at the other thing. That's why but special relativity does explain everything. That, basically, that in terms of mechanics.
So I guess, in terms of how you test these things, in terms of like things like probability, what does that actually mean when you're talking about doing a test for something? Um, like, are you doing, so when you're taking these millions of, images or whatever it is, and filtering through the data, is that creating the probability model for something? Like, how does it work in terms of the experiments that you do to generate that probability?
So
Or is it
we
maths that first predicts it, and then you observe it
Yeah,
after
I
that?
think the maths is a big part of it. I mean, we look at the models, the probability, and then we know what kind of prediction, um, what kind of predictions we need to then go and look for, and we know whether or not we have, maybe, with the Higgs. I guess we had an idea about how much data we need to see it, because we knew what the theoretical probability was of it decaying a certain way. So we then could know approximately how much data we needed to see it. And so these things are all kind of, it helps us. It helps us because it gives us at least the right ballpark, and then we go and find out exactly, what the mass of the Higgs was. But we had some idea maybe about its decay rate and its mass, that we didn't know until we exactly found it. So I think it kind of, having the predictions and the probabilities helps you in shaping your research and your analysis to kind of, get closer to what the correct answer is.
I guess the final question on this part of it. So when you have these people work out these theories, how are they doing that? Are they using data that's already been found, or are they doing it purely from kind of like?
Yeah, whenever we publish a paper, we make available all of the raw data that went into the result to the theorists.
Yeah.
And then they are able to use it directly in their models.
I see.
And play around with it and see, like, okay, so, this is the experimental data now that I have. So now I can, instead of guessing at what happened in this bit, I can now use the actual experimental data and see what happens to my model.
Ah, I see. So it's kind of like an iterative.
Yeah.
I see. Okay, cool.